Okay, hello everyone. Let us continue the second part of today's class. Okay, let us see the handout. In the first part of today's class, we have finished introduce what is maximum likelihood estimation. Okay, then let us see problem 52. What is measurable? Okay, why do we need to know what is measurable? Okay, because let me show you. Okay, let us search for measurable in this document. Okay, so in here it is the first appearance of the word measurable. Okay. Okay, and this is the solution. Okay, to problem 51. What is maximum likelihood estimation? Okay, so let us see what is measurable. Okay, solution. Let x sigma and yt be measurable spaces. Okay, we will introduce what are measurable spaces later, meaning that x and y are sets equipped with respective sigma algebras. I will introduce what are sigma algebras later. Sigma and t. Okay. A function f x to y. Okay, do you remember what does this mean? Okay, this means that there is a function f. Okay, the domain of this function f is x, and the range of function f is y. Okay, is said to be measurable if for every e in T, the preimage of E under F is in sigma. Okay. So what does this mean? What is preimage? Okay. We will explain it in the next sentence. Okay. That is for all E in T, F inverse of E is defined as, okay, the set which contains all small x in capital X, okay, and such that f of small x is in E, okay, and it is in sigma. Okay, this set is in sigma. Okay, that is sigma of f is a subset of sigma or equal to sigma, where sigma f is the sigma algebra generated by f. Okay, what is the sigma algebra generated by f? I will introduce it later. Okay, if f from x to y is a measurable function, we will write, okay, f from x sigma, okay, this pair, to yt, okay, this pair. To emphasize the dependence on the sigma algebras sigma and t. Okay, next let us see problem 53. What is a measurable space? Okay, why do we need to know what is a measurable space? Okay, because it appears in the solution to problem 52. What is measurable? Okay. Okay, solution. Consider a set X and a sigma algebra. Okay, I will introduce what is a sigma algebra in the next problem. A on X, then the tuple XA is called a measurable space. Excuse me. Okay, so next, problem 54. What is a sigma algebra? Okay. Okay, solution. Let X be some set, and let P of X represent its power set. Okay, I will introduce what is power set later. Then a subset sigma is a subset of P of X, or sigma is equal to P of X. It's called a sigma algebra if it satisfies the following three properties. Okay, first, X is in sigma, and X is considered to be the universal set in the following context. Excuse me. Okay, 2. Sigma is closed under complementation. Okay, if A is in sigma, then so is its complement. Okay, X minus A. Okay, this black slash denotes the set minus. Okay, that is X minus A is another set. Okay, and the set contains elements which is in X but is not in A. Okay, 3. Sigma is closed under countable unions. If A1, A2, A3 are in sigma, then so is A, which is equal to A1 union A2 union A3 union, okay, etc. Okay, from these properties, it follows that the sigma algebra is also closed under countable intersections by applying De Morgan's laws. Okay, I will introduce what is De Morgan's laws. What are De Morgan's laws later. Okay, and after learning what are De Morgan's laws, I think that you can easily prove the sigma algebra is also closed under countable intersections. Okay, it also follows that the empty set, okay, this symbol is in sigma, since by 1 X is in sigma. Okay, we can see that 1 X is in sigma, and 2 asserts that its complement, the empty set, is also in sigma. Okay, 2. Okay, sigma is closed under complementation. Okay, so if A is in sigma, then so is its complement, X minus A. Okay, so excuse me. Okay, and moreover, since the set which contains the set X and the empty set satisfies condition 3 as well. Okay, condition 3 says said that sigma is closed under countable unions. Okay, if A1, A2, A3 are in sigma, now we replaced A1 by X and A2 by empty set. Okay, and we do not need to consider An, for n is greater than or equal to 3. Okay, because now we only have 2 sets. So X and phi are in sigma, then so is A, which is equal to A1 union A2, okay, which is equal to X union the empty set, which is equal to X. Okay, so of course X is also in sigma. Okay, so Since the set which contains the set X and the empty set satisfies condition 3 as well, it follows that X phi is the smallest possible sigma algebra on X. Okay, the largest possible sigma algebra on X is P of X. Elements of the sigma algebra are called measurable sets. Okay. So next, let us see problem 55. What is the power set? Okay, why do we need to know what is the power set? Okay, because it appeared in the solution. Okay, here, power set. Solution to problem 54. What is a sigma algebra? Okay. So solution in mathematics, the power set or power set. Okay, you can write power set in 2 words or combine them into 1 word. Okay. Of a set S is the set of all subsets of S including the empty set and S itself. The power set of S is variously denoted as P of S. Okay, P of S, P of S, P of S, P of S. Okay, you can see that these 5 symbols are all called P of S. However, P has different font or different style. Okay, or 2 to the power of S. The notation 2 to the power of S, meaning the set of all functions from S to a given set of 2 elements. For example, the set which contains 0 and 1 is used because the power set of S can be identified with, equivalent to, or bijective. Okay, what is bijective? Okay, I have make a hyperlink here. You can click on it, and you can see that I have introduced it before. Okay, please see problem 22. What is a one-to-one correspondence? Okay, solution. In mathematics, a bijection, also known as a bijective function, okay, and so on. Okay, if you forget what is a bijective function, please review this solution. Okay, let us go back to the bijective. Okay. Okay, or bijective to the set of all the functions from S to the given 2 elements set. Okay. Any subset of P of S is called a family of sets over S. Next, let us see an example. If S is the set which contains elements X, Y, and Z, then all the subsets of S are. Okay. Okay, so first it is a pair of brackets. Okay, it is also denoted this symbol or this symbol, the empty set or the null set. Okay. Next, the set that contains the element X. Next, the set that contains element Y. Next, the set that contains element Z. And next, the set that contains x, y. And next, the set that contains xz. And next, the set that contains y and z. And finally, the set that contains x, y, and z. And hence the power set of S is another set. Okay, this set. Okay, please note that this set has 8 elements, and each element is a set. So the first element is the empty set. The second element is a set that contains x. The third element is a set that contains y. The fourth element is a set that contains z. Okay. The fifth element is a set, the set that contains x and y. Okay, the next element is the set that contains x and z. The next element is the set which contains y and z. And the last element is the set which contains x, y, and z. Okay, please see figure 31. Okay, let us see figure 31. Okay, figure 31 shows the elements of the power set of this set, okay, which contains x, y, and z, ordered with respect to inclusion. Okay, so let us make this figure smaller. Okay, so we know that the power set of this set, okay, the set that contains x, y, z, okay, contains 8 set. Okay, that is the empty set. Okay, and the set that contains x, the set that contains y, the set that contains z. And these 3 sets all includes the empty set. And the set of which contains x, y, okay, and this set includes this set, okay, and this set. And the set which contains x and z, and which includes this set and this set. Okay, and the set which contains y and z, which includes this set and this set. And finally, the set, okay, which contains x, y, and z, which includes this set, and this set. Okay, this is the power set. Okay, next, problem 56. What are De Morgan's laws? Okay, solution in set theory and Boolean algebra. De Morgan's laws are written formally as, okay, let me explain the meaning of these symbols. Okay, A and B are sets. A bar is the complement of A. This symbol, we can read it as the cap. Okay, CAP, cap, is the intersection, and this symbol, okay, you can read it as cup, 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 is the union. Okay, so the complement of A union B is equal to the complement of A intersection the complement of B, and the complement of A intersection B is equal to the complement of A union the complement of B. Okay, so please see figure 32. Okay, let us see figure 32. Okay, figure 32 shows De Morgan's laws represented with Venn diagrams. In each case, the resultant set is the set of all points in any shade of blue. Okay, so let us see the first figure. Okay, this figure. Okay, good. So in this figure, we can see that this blue box, or I should say blue rectangle, we call it U, which is the universal set. And this yellow disk, we call it the set A, and this yellow disk, we call it set B. Okay, so first, A union B is this set. Okay, and the complement of A union B is the blue part. Okay, and it is equal to the complement of A. Okay, that is U minus A. Okay, so this is this rectangle minus this disk. Okay, so this region. Okay, and the intersection, the complement of B. Okay, so the complement B is equal to U minus B. Okay, this rectangle, okay, minus this yellow disk, so is this region. Okay, so the intersection of these two is also this set. Okay, sorry, the U minus the yellow set, which is the blue part. Okay, next let us see the second figure. Okay, in second figure we also have a blue rectangle U, okay, which is the universal set. So first let us compute A intersection B. Okay, A intersection B, this set, and the complement of A intersection B, which is the blue part. Okay, and this is equal to the complement of A. Okay, the complement of A is U minus A. Okay, that is this rectangle minus this disk. So is this area. Okay, and the union with the complement of B. So the complement of B is U. Okay, this blue rectangle minus this disk. So the resultant region is this region. Okay, so complement of A union complement of B, okay, is the blue part. So you can see that these two terms are equal to each other. Okay, these are De Morgan's laws. Okay, okay, so this is figure 32. Okay, let us go back to figure 32. Okay, here. So next, problem 57. What is the sigma algebra generated by F? Okay, why do we need to know what is the sigma algebra generated by F? Okay, because we have mentioned it in. Okay, let us see. Okay, here. Sigma algebra generated by F in the solution to problem 52. What is measurable? Okay. Okay, so let us see the solution. If okay, it is 25 minutes. Let us take a break.